Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Researchers have developed a new technique, called MonoCon, that improves the ability of artificial intelligence (AI) programs to identify three-dimensional (3D) objects, and how those objects relate to each other in space, using two-dimensional (2D) images. For example, the work would help the AI used in autonomous vehicles navigate in relation to other vehicles using the 2D images it receives from an onboard camera. We live in a 3D world, but when you take a picture, it records that world in a 2D image, says Tianfu Wu, corresponding author of a paper on the work and an assistant professor of electrical and computer engineering at North Carolina State University. In this research, we are focused on one part of that challenge: how we can get AI to accurately recognize 3D objects, such as people or cars, in 2D images, and place those objects in space. While the work may be important for autonomous vehicles, it also has applications for manufacturing and RO. In the context of autonomous vehicles, most existing systems rely on lidar, which uses lasers to measure distance, to navigate 3D space. However, lidar technology is expensive. And because lidar is expensive, autonomous systems don't include much redundancy. For example, it would be too expensive to put dozens of lidar sensors on a mass-produced driverless car. But if an autonomous vehicle could use visual inputs to navigate through space, you could build in redundancy, Wu says. Because cameras are significantly less expensive than lidar, it would be economically feasible to include additional cameras, building redundancy into the system and making it both safer and more robust. That's one practical application. However, we're also excited about the fundamental advance of this work, that it is possible to get 3D data from 2D objects. Specifically, MonoCon is capable of identifying 3D objects in 2D images and placing them in a bounding box, which effectively tells the AI the outermost edges of the relief. These boxes are cuboids, which have 8 points. Think of the corners on a shoebox. During training, the AI is given 3D coordinates for each of the box's 8 corners, so that the AI understands the height, width and length of the bounding box, as well as the distance between each of those corners and the camera. The training technique uses this to teach the AI how to estimate the dimensions of each bounding box and instructs the AI to predict the distance between the camera and the car. After each prediction, the trainers correct the AI, giving it the correct answers. Over time, this allows the AI to get better and better at identifying objects, placing them in a bounding box, and estimating the dimensions of the objects. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.